this is Miss Anggun speaking again. Welcome back to my channel. Today we will move on to the next topic in chemistry, in which we will be talking about purity, and I'm going to show you a bit of sample of separation methods. So I hope you can enjoy this video and learn something from it. Let us talk about purity first. So what is purity? When I show you my distilled water in a container like this, you know that it contains only water. There is no mineral, there is no organic substances inside the distilled water. So we can say the purity of this distilled water close to 100%. Why? Because it only contains water. There is no other thing. So, is purity always good every time? Well, not always. This is people's favorite. This is boba tea. Now, you know that you don't want this boba tea to be pure water, right? It will be less enjoyable. So sometimes we need something to not be pure, because when it becomes a mixture, we enjoy it a bit more. So purity and mixture is good, depends on the condition. Say for example, drug. Some drugs are delivered into patient's body in the form of pure substance. Now, of course, we don't want it to be impure. We don't want any other impurities to be coming or to be inserted into our body, right? Because they will be bad. So in the example of drugs, we want it to be as pure as possible to make sure that the drug can do its job. What about food then? Well, most of the times, food is a good example of mixture. Well, of course, after it becomes a mixture, do we want such impurities, for example, dirt, to be put into our food? No, we don't want it. We don't like it. It's gross, right? We want it to be clean, we want it to be good, but after all, we want it to be enjoyable but also safe to eat. Today, I have two ways to determine whether a substance is pure or not. The first one is called chromatography, using just simple plain filter paper and water. The second one is using boiling point. Paper chromatography is pretty simple. You only need a pencil, a ruler, and a piece of plain paper. Here, I use a cut-out filter paper. You also need something to hang the paper after this. Paper chromatography is a fun way to identify components in a mixture. I have 3 different food colorings which I will try to separate in this experiment. Those colors are purple, brown, and green. Note that I give some space between each color, because sometimes a color spreads out during separation. We don't want them to bleed into each other. We know that pure water boils at exactly 100 degrees Celsius at 1 atmospheric pressure. But when we begin to mix water with something, for example salt, the boiling point will change. Don't forget your safety goggles, your gloves, and your lab coat. We'll try to see whether a pure liquid will have a different boiling point than a mixture. We're going to find out. First, we need a Bunsen burner and we need to light it up. Open the gas. Okay, your lighter on your left hand, your right hand on this gas. And then the air. I don't know whether it's seen in the camera, but the blue flame is supposed to be there and I can see it. The other thing that you need is a tripod and a gauze. This is a mixture between salt and water, and we will try to boil it and see whether it has a different boiling point than pure water. We wait. When the mixture of water and salt boils, I carefully measure the temperature using thermometer. It is 103 degrees Celsius. Presence of impurities like salt will change the boiling point of water. Different amount and type of the impurities will give different boiling point too. And this is our conclusion. As a chemistry student, you should be able to know, understand, and do some simple separation methods such as filtration and evaporation. Let's see how I do it. I am going to make a mixture first. Inside the beaker is a mixture of salt and water. I am going to add mung beans to it. I also add powdered chalk or calcium carbonate to the mixture. Chalk does not dissolve in water. Simple filtration using filter paper in a funnel separates mung beans instantly. It is because the size of the mung bean is much bigger than the size of the pores of the filter paper. We may need to repeat filtration with new filter paper to completely separate powdered chalk from the mixture. After the chalk is removed, a clear solution is obtained. Salt has dissolved well in this solution. We cannot use simple filtration to separate the salt. We have to use evaporation. Solution mixture is put into a ceramic evaporating dish and the water is boiled away to leave salt behind as a white crystal on the bottom of the dish. It's important not to completely dry the crystals because some of the salt might decompose on further heating. So we will just air dry it. And that's a wrap of our chemistry session today. I hope you can actually learn something from it and see you around. We know that pure water boils at exactly 100% degree. 100%? Why? What happened with me?